Hello, friends. This is probability day 3, April 2nd or 3rd, depending on odd or even day it is for you. Today's anti-set is a frequency table. Please make sure that you submit your textbook homework via Google Classroom by the end of the day today. The answers are in here after I tell you what today's objective is. So if you do want to check your answers before you submit it, you may do so. All right, so let's take a look at this warm-up here. Students were asked about the number of siblings they have. The results of the survey is in the frequency table. Find the following probabilities. The probability of having 2 siblings, probability of fewer than 3 siblings, and the probability more than 1 sibling. So again, we need to figure out the total frequency. And this total frequency here is 39. So the probability of having 2 siblings, we'll go to the number of siblings for 2. There are 15 of them, so it'll be 15 out of 39. Fewer than 3 siblings. All right, for that one, I would have to add up these 3 here, 2, 1, and 0. So 15 and 12 is 27, plus another 5 is 32 out of 39. And then the last one here is more than 1 sibling. More than 1 sibling. More than 1 would have to be the amounts of 2 and 3 siblings together. And that would be 22 out of 39 total. Okay, today's objective is ELR 13.3. You definitely need a calculator for today. A TI calculator. Will be looking for buttons that are representing probability. I also found something that you could download through your phone, through an app store. It's called Calculate 84. So I'm just going to write it over here, Calculate 84. That you could download on your phone, and it looks just like a calculator in your hand. That's another possibility if you don't have a calculator available with you. So today we're going to be talking about what's the difference between a permutation and a combination. We will be printing out, so maybe before you get started for today, there is something to print out called a permutation combination foldable. If I was in school, I would have printed it out on a specific color and have you guys, fold it and piece it in your book. It's up to you if you could figure out how to configure it and print it out, or to have part of it in your notebook so that you can have examples to look at. And you'll be doing pages 3 and 4 to put in your notebook. And page 5 of that PDF has the answers, so you could check yourself there. And then, besides doing the foldable in your notebooks and the notes, you will be doing this task card activity that is also a PDF in the agenda for today. So you'll be taking a look at that. You'll be submitting 10 out of the 16 there via Google Classroom, which is going to count for your attendance for today. All right, so the first thing we're going to be talking about today is how do we order things in probability. So if I asked you to list the possible order of watching 3 different types of movie, we have a comedy, a drama, and an action. There are 2 different ways to list these possible orders. One is in a list, and one is in a tree diagram. So let's first show the list. So a list means I'm going to be actually putting them down. And I'm going to abbreviate C for comedy, D for drama, and A for action. So one possible combination of viewing these is comedy, drama, action. So I'm separating them by commas, kind of like an ordered pair, but there are 3 different possible things there. So I'm trying to rearrange those 3 possible letters in all possible combinations. So you guys keep going. We have a comedy, action, drama possibility of watching. Then I could watch drama first, comedy, then action. Then I could do drama, action, comedy. I could do action, comedy, drama, and then action, drama, comedy. That is in a list. I could also do it in a tree diagram way. So it means a tree diagram because you actually have lines that look like branches for this. So I'm going to start off with 3 because I have 3 possible things. I have comedy, drama, action. So if I watch comedy first, I either have a possibility of then watching drama or action. If I watch comedy, drama, last possibility then would be the action movie. Or if I went along this branch here, I could have watched comedy first, then action, and then drama last. If I start with drama first, I have a possibility of comedy and action. And then if I do the branch this way, drama, comedy, my other possibility after that obviously is action. If I do dramedy, action, last combination would be comedy. And then if I start from the beginning again, if I first start with the action movie first, then I have the possibility of comedy and drama. And depending on which way I go along this branch, I fill in the rest. So just take a look over here. So this is one whole branch, comedy, drama, action, which I have here on the top. Then comedy, action, drama is what I have over here. And I look along this branch, this is what I have over here, drama, comedy, action. This 4th branch here, drama, action, comedy is I have the same list over here on the left. And then action, comedy, oops, this should be a D, this thing here. This would be the 5th list in the list, and then this is the last part of the list. So 2 different ways to represent an order of things. One is as a list, and one is as a tree diagram. Okay, sometimes we need lists to answer questions that are dealing with something called the fundamental counting principle. So this is ELR 13.3. This is an important definition in your notebook. If there are m ways to make the first selection and n ways to make a second selection, then to get the total number of ways would be m times n. So I'm multiplying there to get the total amount of outcomes. All right, here's the first example. A deli offers a lunch special if you choose one from each of the following. We have sandwiches, we have a side item, and we have drinks. How many different lunch specials are possible? So here, we're looking for how many possible combinations I can have of this. So instead of trying to make a huge list of this or a tree diagram, which would be so big, we are going to be using the fundamental counting principle, which says I could take my m possibilities and my n possibilities and multiply them together. Well, here I have 3 things to pick from the lunch special. I have sandwiches, I have a side item, and I have drinks. So I need to count how many sandwiches possible that I could choose from. There are 6. There are 4 side items, and there are 5 possible drinks. So instead of just 2 things being multiplied, I'm going to be multiplying 3 numbers here. 6 times 4 times 5. So I have 120 possible lunch specials. All right, here's a second example. You wake up in the morning, you need to choose an outfit for school. You have a choice of 6 pants, 10 shirts, and 15 pairs of shoes. How many possible outfits can I choose from? So again, I'm using my fundamental counting principle. I'm going to be multiplying things here. Here I have 6 possible pants, 10 possible shirts, and 15 possible pairs of shoes. When I multiply these all together, I have a possibility of 900 outfits. That's crazy, right? All right, now what's going to happen is now we need to figure out the arrangement of the objects. So a permutation, which is another example, definition you should have in your notes, is the arrangement of objects in which the order of the objects is important. So that's why I have it in red. Order is important. We represent a permutation in two different ways. One way is with this sign. They call it n factorial. It's n with an exclamation mark there. And it says it equals n times n minus 1 times n minus 2 times n minus 3, so on and so forth until you get all the way down to 3 times 2 times 1. I'm going to show you what this is on the calculator and also how to do this by hand. So, first example here says, how many ways can you file 12 folders, one after another, in a drawer? All right, so we know we have a total of 12 folders, one after the other in a drawer. So if you think about it, order is important because for the first possible spot, there are only 12 possibilities, then 11, then 10, then 9, and it keeps going down because I already used the previous one from before. That's 2 times 1. So this thing here, 12 times 11 times 10, all the way down to 1, is 12 factorial. This is exactly what you're doing to get the answer for 12 factorial. So I could go ahead and multiply all these numbers out on the calculator. There is a button on the calculator, which I'm going to show you right now where that is on the TI. So go ahead and get your calculators. All right, so I am looking for the button that says factorial. So if you turn on the computer, press your math button here, math button right here. And then on the top, we have lots of different things: math, num, complex, prob, frac. You want to move all the way over to the prob highlighted. And then take a look. We have 2, 3, and 4. Those are the ones that we'll be using there. Permutation, combination, and number 4 is the factorial. Hopefully everyone could see that. So take a look on your calculator, math button all the way over to prob. We're looking at number 4. Now before you actually press 4, you need to go back to the main screen and press in 12 first. Then do math over to prob. Press number 4 and then enter. And it should give you this answer. So pause the video, try it, see if you can figure it out. Okay, here's a second question. You can download 8 songs on your phone. If you play the songs using random shuffle option, how many different ways can the sequence be played? All need to be played and only once. And because they have that in the parentheses, that means order does matter here. And how many ways can I download 8 songs? Well, that's 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Or simplified version is that 8 factorial. Again, if I do it in the calculator, math over to prob down to number 4, I get 40,320 ways to download songs, to play songs at random. Okay, another way to represent permutation is specifically when we're looking for an arrangement of objects, again, in specific order. Order is important for permutations, but we're not going to be choosing everything that's given to us, like the other 2 problems where we had to choose the 8 songs, choose the all 12 file folders. Here we have a symbol. It's a permutation of n objects taken r at a time. So n, the number on the left, the subscript, is the total amount of objects. R, the other subscript on the right-hand side, is the amount of objects you're choosing from the total of n. And there is actually a formula for this, but we're going to be using the calculator to get the answer though. And the way to figure it out is to use factorials. So we would do n factorial, all divided by the n minusing the r, and taking the factorial of that subtraction. I'm also going to be showing you this on the calculator. So let's go back to that example that we had before about the 8 downloaded songs. Perhaps you only want 3 to be played at random from the 8. How many ways can that happen? So we are going to be doing a permutation. The total objects, the bigger numbers on the left side is 8. And I only want to choose 3 of the 8 to be played at random. So if I was to do the formula way, this is my n and this is my r, I would do 8 factorial divided by 8 minus 3 factorial. So it's 8 factorial divided by 5 factorial. And if I actually was to write it out with all my math, this is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 5 times 4 times 3 times 2 times 1. All right, what cancels out, everybody, is the 5, 4, 3, 2, 1. And I'm left with 8 times 7 times 6, which is 336 possible ways to play the 3 at random from the 8. All right, on the calculator part, still would be pressing the math button, going all the way over to the right to prob, and we're going down to now number 2. Now, if you have a newer version, when you press number 2, it should come up like this. And you would move your cursor, put the 8 on the left, the 3 on the right, enter, and you'll get your amount of ways, which we did manually before, 336 ways. I believe if you have a TI-83, you need to put the 8 in first, then go to math, over to probability, press number 2, and then you would input 3. So those that have different versions of the calculator, if you're having trouble, please let me know. I'll try as best as I can to explain it to you. But this is for the 84. Try it, see if you could get it. Okay, here in this example, we have 10 students are in a race. First, second, and third place will win medals. In how many ways can the 10 runners finish first, second, and third? No ties. So is order important here? Yes, because you're getting to be first, second, and third place. So I'm going to show you 2 different ways of answering this type of question. How many ways can 10 runners finish first, second, and third? So if I was to do the fundamental counting principle way, well, how many people can win going in for first place? 10 possible people, correct? If then that person won for first place, how many are left to win second place? 9. That person won second place. How many people are left for third place? 8. And the fundamental counting principle says you would take those 3 things and multiply them together, 10 times 9 times 8, which would be 720 ways for these guys to win first, second, and third. If I was to do it the permutation way, I would have a permutation, 10 altogether for runners, and because I only have 3 slots, first, second, and third, I'm going to have it choosing 3 things, 3 as the R. Go ahead and practice this in your calculator, 10p3, and you should also get 720 ways. Okay, last thing for this section, combination. A combination is all a selection of items. This time, order is not important. Not important, the order. So let's go back to the very beginning of the lesson where we had to make a list and a tree diagram for the action, comedy, and drama possibilities. So if ordered mattered, which is a permutation, how many possible arrangements could there be of those 3 types of movies? There would be 6. 6 of them that are important. If order did not matter of choosing it, then this would be a combination. And then they would only have one possible arrangement because they're all the same anyway, because order doesn't matter. So a combination would have only one thing here. Didn't matter the order as it did for a permutation. The symbol for a combination is a capital C. And it has the same letters as the permutation, N, number of total objects on the left. And how many are we choosing from N is the one on the right-hand side. The formula for this one is a little different. You're doing N factorial divided by R factorial times N minus R factorial being multiplied to that and divided. All right, so I want to go back to this question here. About the action, comedy, and drama. So let's say I wanted to pick the movies that I could watch out of those 6. All right, here in this example, 20 people report for jury duty. How many 12-person juries can be chosen? So in this question, it doesn't matter how they're choosing the 10 people. So order is not important. So we know it's a combination. So we're going to be choosing 12 from the 20. So we're going to have a combination. 20 is the N. 12 is the amount, the R that we're going to be choosing. If I was to do the formula way, I would have it as 20 factorial on the top divided by 12 factorial times 20 minus 12 factorial. Work this all out. And these are big high numbers. You would work it out, cancel things out. If you try it in the calculator, so again, go to math, over to prob, and it's down to, I believe, what was it again? Number 3 this time. And you're doing N, and here's the R. Press enter. You should get 125,970 ways to choose a 12-person jury. Okay, if you need to take yourself a break and then keep, a 5-minute break and then continue with the notes, please do so. This is a pretty long lesson today about permutations and combinations. Okay, so this next slide, and this will be one of the last ones before you then print out that foldable and do the examples on that, is identifying, not even solving it, just identifying if the question is a permutation or a combination problem. So you must remember again that in a permutation, order matters, and in a combination, order does not matter. I have 3 different questions here below, number 1, number 2, and number 3. Go ahead and read those 3 and decide for yourself if that is a permutation or a combination. All right, question 1, a college student is choosing 3 classes to take during first, second, and third semester. From the 5 elective classes offered in his major, how many possible ways can the student schedule these 3 classes? Well, order is definitely important for these 3. So number 1 is a permutation. For number 2, a jury of 12 people is chosen from a pool of 35 potential jurors. How many different juries can be chosen? Order doesn't matter for this, about how you choose people. So this is a combination. Number 3, a yogurt shop allows you to choose any of the 3 out of 10 possible mix-ins for a smoothie. How many different smoothies are possible? Okay, doesn't say that they want a specific way to make this smoothie, and they're just going to mix them all together anyway, right? So this is, order doesn't matter here. This is another combination. All right, we have 2 examples here. 3 balls are randomly chosen from a set of balls from numbered 1 to 15. What's the probability that the pool balls chosen are numbered 5, 7, and 9? All right, so we need to figure out the probability of choosing the numbers 5, 7, and 9 out of a total of all 15 of them. So our first step is to figure out, okay, what is going to be the setup of our fraction. So first, step 1, you want to know what's the probability of getting a 5, a 7, and a 9. So we need to figure that number of ways to choose 5, 7, and 9. And then on the denominator, number of ways to choose 3 balls out of the 15. All right, so let's figure out the number of ways to choose 5, 7, and 9. So 3 possible ways to get 5, 7, and 9 for the first spot. Once you've chosen one of those, how many are left? 2. And then once you've chosen the second one, how many left? Just 1. So there are 6 possible ways to choose 5, 7, and 9 for the numerator. Step 3, the denominator. Here, doesn't matter the order of choosing the 3 out of the 15. So this is a combination problem. So I need to figure out what's the combination, 15 altogether, and all I want is 3 of them to be chosen. You put that in the calculator, and I get it to be 455. Now the last step is to put those 2 answers together in our fraction for step 1. So I have 6 out of the 455 possible outcomes. In the calculator there as a decimal, it comes out to 0.013, which is about a 1.3% probability that you will choose the number 5, 7, and 9. Okay, the problem below it, what's the probability of first choosing the number 1 ball, the number 2 ball, and then the number 3 ball? Here, order is important. So we're going to be going through those steps again. So step 1, what's the probability of choosing 1, then 2, and then 3, right? So 1 would be first, 2 would be second, 3 would be third, over the number of ways to choose the 3 out of the 15. All right, so let's do the top first, step 2. What's the probability of getting number 1 first? Well, we want number 1 first, so there's only one possible number 1 for the first spot. Okay, to choose the ball number 2 second. Well, there's only one number 2 ball, and it must be second, so there's only one possible way to get 2. And then for getting the number 3 ball for the third spot, there's only one possible 3 ball for the third spot. So if I multiply these all together, is 1. Step 3 now, the denominator. We know it's a permutation because the order matters for the first, the second, and the third ball. So I'm going to do permutation in my calculator, 15, choosing 3 of those balls. I get it to be 2,730 possible ways. Step 4 is to put these all together. So the top of the fraction was 1. The bottom of the fraction was 2,730. Okay, so I'm not going to be checking that you have printed out that foldable. My suggestion is to definitely do it. Take a look at it. Printing out pages 3 and 4 somehow, gluing it in or stapling it in your notebook. You could find the answer key on that page 5 of that PDF document. The one thing that you definitely need to do by the end of the day is doing that task card PDF activity. So if you open up that PDF, there are 16 cards. All I need you to do is answer only 10 of them. So if you want to connect with others in class to work on it, you can. I have attached a Google document for each of you that you will submit to me with your work shown and the answer of the 10 that you chose. And this will count as your attendance for today. If you do want to work with each other, you may during this time. Just be careful. Please ask any questions that you have. I'm available. Just email me. So that's the last thing that will be required for today's class. There is no homework over the weekend. Your exit ticket is just to finish up those task cards, choosing the 10 out of the 16, showing your work and submitting that to me through Google Classroom. Hang in there, everybody. No homework this weekend. Again, any kind of questions you have, please email me. I'll be doing office hours next week for sure during my assigned time during Tuesday after school. I'll do it for about 45 minutes from 3:15 to 4, and I'll send that out next week for you. And that will be through Google Hangouts if you have any questions. Monday's lesson is going to be a review of what we did so far from this week, especially with the permutation and combination stuff. Have a great weekend, everyone, and I'll be speaking to you all soon.